Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, so in this video we're going to look at unit tests in C#. And unit tests are something that we want to be able to do. We want to be able to test our classes. As we've been doing so far, we've been putting in our own sample data and our own test data and kind of just verifying ourselves by eye that things are working as they should. But a more professional or a more methodical approach is to use unit tests. And really what we mean when we say unit, this is, in our case, it's really going to be classes and methods. They're going to be our units. Okay, so we're going to test methods one at a time. Each method will just be its own unit. So once we get a method working as expected, then we can write a test for that method. Then we can build up all of them units into our whole tester class then. So what I'm going to do is just walk through a Microsoft tutorial. And this tutorial that I've got from Microsoft themselves, I'll put the link in the description, but it's just applies to Visual Studio, so this doesn't work for VS Code, for example, and it's Visual Studio on a Windows machine. So if you have a Windows machine or a Mac, or maybe you might be using VS Code for some reason, you will have the option on Microsoft's own website to go and find the same walkthrough. But anyway, this is on a Windows machine, so this article steps you through creating, running and customizing a series of unit tests using the Microsoft Unit Test Framework for Managed Code and Visual Studio Test Explorer. So we'll have a look at what that is later. So you start with a C# project that is under development. Create tests that exercise its code, run the tests and examine the results. Then you change the project code and rerun the tests. If you'd like a conceptual overview, go to that link for unit test basics. But if we think about our library of classes, as we start to build our libraries now, we have to make sure that our classes are robust. So what I mean by robust is, for example, that they don't throw any exceptions, or they don't have any fatal errors if a user puts in the wrong type of data, or the wrong they put in some unexpected data that we weren't kind of prepared for the method to handle. So yeah, the good thing is that once we can create these unit tests for the classes, and if we think about a class is built up of little units, and each unit is a method. So we can look at, as we said in previous videos, a method should just do one job and one job only. So let's say it's a method to add two numbers. If I put in a 2 and a 3, then it should return me a 5. So we're basically writing tests. We're writing program code that will do this testing for us in an automated manner. So that's really the benefit of unit tests, is basically automating the testing of our code. But if we think about our library as a collection of classes, so if you're writing a library, let's say we're working on the .NET framework here, so somebody somewhere along the line had to write the classes in that library. Or if you're using the Java framework, then the Java API, somebody had to sit down, or many developers had to sit down and write the classes in them libraries. So if you think of a library as a wall, your classes are like your bricks that make that wall. Okay, so your wall is only as strong as your individual bricks that make it up. So what we're doing when we're testing our individual classes in units, or doing our unit tests, what we're doing is we're testing each individual block in that wall. So as we're building the wall with our blocks, with our classes, then we know that the integrity of each class or each block in that wall is, as strong as we can make it. So that's really, when they say about the basics of unit tests, we just want to make our programs robust and basically stop them from falling over, stop them from causing unexpected errors when people, use our code in unexpected ways. Okay, so first, this gets us to create a project to test. Okay, so at this stage we do have projects to test, but we'll be doing that in the practical. But for now, we'll just go with this. We'll create this project for this tutorial. So on the start window, choose create a new project. Search for the console app. Okay, and it's .NET. Click next. So name the project bank. For this, I'm not going to commit it to GitHub. I'm going to just put it somewhere else. C# projects. And leave the solution name the same. So click next. Choose either the recommended target framework or .NET 6 and then choose create. I'll go with .NET 6. And so if program is not open in the editor, okay. Didn't have that problem. Visual Studio always takes so long to load these new projects. Let's double click the file program to open it, so it's grand that opened here anyway. Just let it load for a second. Try and get it. Okay. So replace the contents of program.cs with the following C# code that defines a class bank account. Okay, so that's right from the... We'll go over to the tutorial online here. Copy that. Okay. Rename the file to bankaccount.cs. By right-clicking, choosing rename in the Solution Explorer. On the build menu, click Build Solution. There's in the build menu up here. Okay, build solution. You now have a project with methods you can test. In this article, the tests focus on the debit method. The debit method is called when money is withdrawn from an account. Okay, so that's kind of the base behavior that we want to see. We'll kind of talk a bit through this, what's happening here. So we have a couple of private fields here. This is we have a constructor, a custom constructor, and then we have our getters, or our properties that are just read only, so just with get. So look at this debit method here. So if the amount that's being passed in, if the amount that's being debited is greater than the balance, then throw a new exception called argument out of range with the message amount. And if amount's less than 0, so we don't want it to be negative, because that'll actually, if you take a negative away from an amount, it will actually increase the amount. So again, we'll throw the same exception. And then down here we've got some intentionally incorrect code. Okay, so on the file menu, go to add a new project. So add new project, and we want to go for test in the search box. Okay, MS test project. So a project that contains MS test unit tests that can run on .NET, on Windows, Linux and Mac OS. That sounds about right. What do they say here? So on 2019 version, it's unit test project. That's this one, is it? Anyway, we've picked that one, MS test project. And we will call it bank tests. Okay, and it's going in the bank solution. Okay. So it's in the bank solution now, our bank tests. So in the bank test project, add a reference to the, so we know how to do that, to the bank project. Add project reference, click on the bank project and click OK. In the reference manager dialog, select solution and then, oh yeah, right, done all that. Okay, so now to create the test class, so as you can see they've given us a default test method here, so you know it gives you the test class declaration and test method declaration. So hopefully they'll explain what they are now. So create a test class to verify the bank account class. You can use the unittest1.cs file that was generated, but give the file and class more descriptive names. So to rename the file, Solution Explorer bank tests, from choose rename, then rename it to bank account tests. Okay. So right click in the Solution Explorer, rename and call it bank account tests. .cs. Yes, so if it asks you, would you like to rename all the references, just say yes. So that's what it does here basically, you know, it renamed the class and everything for us. So that's handy. So bank tests, bank account tests class, and then test method 1, okay. Add a using statement to say that we're using bank account NS. So what's bank account? Oh yes, that's this namespace here, bank account namespace. That's what NS must stand for. Okay. So our using typically goes before the namespace declaration, but I don't think it matters anyway. So you can see that Visual Studio already recognizes it, so just do that. Save that. So the minimum requirements for a test class are the test class attribute. So here on line 5, it's required on any class that contains unit test methods that you want to run in the Test Explorer. Okay, and each test method that you want the Test Explorer to recognize must have the test method attribute. So this one here on line 8. You can have other classes in a unit test project that do not have a test class attribute, and you can have other methods in a test class that do not have a test method attribute. So you know, you can have just normal methods in this class here, and you can call these other classes and methods from your test methods. So there might be sometimes, you know, when you just want to have a method that does a job for you, but it's not actually, you know, a test method that is going to be, you know, when the test explorer, whenever the tests start running, that it's basically going to ignore that method. It's not going to use it as a test method. So let's create the first test method. In this procedure, you'll write unit test methods to verify the behavior of the debit method of the bank account class. Okay, so this one that we checked before, from 31 down to line 44. So there are at least 3 behaviors that need to be checked, as you can see here. Behavior number 1, 2, and then 3. So the method throws an argument out of range exception if the debit amount is greater than the balance. Okay, this is the first check. The method throws an argument out of range exception if the debit amount is less than 0. Again, second check. And then if the debit amount is valid, the method subtracts the debit amount from the account balance. So you can see ours actually adds it, doesn't subtract. So this is, we've left this intentionally incorrect just to show, you know, for display purposes, I'd imagine it'll be. So to create a first test method, the first test verifies that a valid amount, that is one that is less than the account balance and greater than 0, withdraws the correct amount from the account. Okay, so I'll go back to our test class. Add the following method to the bank account tests. Yeah, so they say here we can delete the default test method 1 because we won't be using it in the walkthrough. So this can actually just be deleted out of there. So debit with valid amount. I'll go back over to online tutorial. Is this it now? Like reading off, printing it out in PDF and reading it because it's a lot cleaner. This verifies that a valid amount, one that's less than the account balance and greater than 0, withdraws the correct amount from the account. So the method is straightforward. It sets up a new bank account object, so this is called account, with a begin balance, and then withdraws a valid amount. It uses the assert.requal method to verify that the ending balance is as expected. Methods such as assert.requal and assert.isTrue and others are frequently used in unit testing. So these will be, you know, typically the way we will run our unit tests. It's just assert that, you know, if my balance is $100 and I take 50 from it, then, you know, assert or check that whatever answer comes back is equal to 50. You know, that might be an example. So a test method must meet the following requirements. It's decorated with this test method attribute. It returns void, and it cannot have parameters because the test explorer is just expecting a certain method signature, and these are two of the conditions that must be met. So it has to be void and it has to have no parameters. Okay, and you can name it whatever you want, but it also has to have this test method declaration. For you're basically saying to the test explorer, this here, test this method here as well. Add this to your list of methods that you want to run when you're testing. Okay, so build and run the test. On the build menu, hit build solution. If a test explorer is not open, open it by choosing test, Windows. Okay, we don't have that, do we? We just have test explorer. Okay, great. So now we can choose run all tests in view. This is just run, so we'll go run all to run the test. While the test is running, the status bar at the top of the test explorer window is animated. So you see that whenever I click go. At the end of the test run, the bar turns green if all the test methods pass, or red if any of the tests fail. So let's, before we go into it, let's just discuss line by line what is happening in the test method. So initially what we're doing is we have a starting balance that's just $11.99. The amount that we're going to debit, and then this is the expected. So what you could do here is we expect beginning balance minus the debit amount, really. So if you were to debug and run that, that'll be the same as what what they put in anyway. But so when we create our new bank account, we need to give it a name and the starting balance. Then we're going to pass in the amount that we want to debit, and then we can see what is the actual balance amount now. So we can just get account dot and then the property balance, the public property, and then we use our assert.r equal. So we just check, is this expected one that we calculated the same as the actual balance that was returned? And this is basically the precision that we're allowing here. Okay, so if it's within 3 decimal places, then that's allow that kind of flexibility. And basically then this is if this doesn't, so if the test fails, what do you want to show the user? So what is the fail message? So basically what's going to happen, I changed that, so I'll just save it there. So in the test explorer, when we say run all, you can see what tests are here. It's showing you. I can see that you've got bank account tests, and I even know the name of it because you've told me what method that that I have access to here, and the test explorer has access to. So we can run all, select a method in test explorer to view the details at the bottom of the window. So I've already had selected here, and I'll go run all, but if you select it, and then you can just run it. So it says that one failed, and as you can see, all the levels all the way up, all these ones, that's just referring to this one. They're just looking at different levels. So assert r equal failed. This is our message. Expected a difference no greater than between the value. So our expected value is 744, and the return value is actually 1654. So account not debited correctly. That's our fail message. So you can see that the test itself gives us a message, but then we can see the message that we've basically said. So that has failed, and that's what we would expect because we had it intentionally wrong. The logic was wrong there in the debit method. So fix the code and rerun the test. The test result contains a message that describes the failure. You may need to drill down to see this message. So yeah, as you can see, I had to drill down there, but once I click on it, then this is my test details summary. For the r equal method, the message displays what was expected and what was actually received. You expect the balance to decrease, but it increased instead by the amount of the withdrawal. So the unit test has uncovered a bug. You got back something different than what you expected. And the amount of withdrawal is added to the account when it should be subtracted. So we can go back and correct this bug. Alright, easy enough. They have it labeled for us. Okay, and then we can just go back and make sure and save this, save the work, and then go back to the test explorer, run all again, or because I have it selected, I can run one at a time, the one I have selected, but I'll just go run all because there's only one. Okay, now you can see pass. That only took 32 milliseconds. So the red green bar turns green to indicate the test passed. So we can use unit test to improve the code. So this section describes how an iterative process of analysis or unit test development and refactoring can help you make your production code more robust and effective. So you can analyze the issues. So you've created a test method to confirm that a valid amount is correctly deducted in the debit method. Okay, that's fair enough. We've basically tested, you know, our behavior. We've tested it with something that is valid. But typically, whenever you're doing tests, what you want to do is you want to test the extremes. You want to think about, you know, the extreme case, or things that the user might pass in that wouldn't be valid. So what you would normally do is you basically verify that if I put in the wrong data, is it going to fail, you know, the test. So we want to verify that the method throws these exceptions if the amount failed, because if you think about what we've done so far, is all we have tested is that amount. We've only really tested this behavior. Okay, we've only tested the main behavior, but we haven't tested yet to see, do these lines of code work? Okay, so you need to, your corner cases or your extremities, you know, the extreme, let's say, you know, we need to test is if somebody puts in less than 0, will it actually throw this exception? Or if they put a, you know, a debit amount that's greater than the balance, will that throw an exception? So we'll go back to our bank account tests, and so this one was with a valid amount, okay, and updates balance. So you want to be as descriptive as possible with your names. So as you can see, you know, sometimes the test method names can get really big, but that's okay because you want to, you know, have them really descriptive and say what the test does almost in the name. So I'll copy this. Yeah, they get us to verify correct behavior when the amount is less than 0. So we'll put this after here. When amount is less than 0, and then this is what, you know, should happen. So this is the method that we're testing. We're testing it with a valid amount here, and then it should update the balance, you know, correctly. So that is when you come back to your method and you look at the debit method, it's really just testing, you know, that's what that method is testing. It's testing that behavior. It should update the balance. But then this one should throw an argument out of range exception, because what we're going to do is we're going to pass in when the amount is less than 0, the debit amount is less than 0. Okay, so you can see here our debit amount's minus, and then whenever we're looking at the assert, so in this one, throws exception. So we can say, you know, assert that it throws this type of exception whenever I pass in the account, or sorry, this debit amount to the debit method to that new bank account. So uses the throw exception method to assert the correct exception has been thrown. In this case, I think isn't the two exceptions of the same type anyway, so I suppose that doesn't really matter. But yeah, you basically need to say, you know, you have to have the right type is in. If you temporarily modify the method under test to throw a more generic application exception when the debit amount is less than 0, the test behaves correctly. That is, it fails. So to test the case when the amount withdrawn is greater than the balance, do the following steps. Create a method called when it's more than, should be out of range. So what I'm going to do is just copy this and change the name. When amount is more than balance. Balance, and that should throw a argument out of range. Okay. Set the debit amount to a number greater than the balance, so we'll just go plus 100. Okay, and run the two tests and verify that they pass. So now you know these two new tests, hit save, and they should be now, yeah, they're here, but you can see this little, you know, this little symbol saying we haven't tried to run this test yet. So we'll just run all again. Okay, happy days, they passed. And what did they say? Yeah, so that's, they passed, so they've obviously thrown the right exception. So the method being tested can be improved further. This method. With the current implementation, we have no way to know which condition led to the exception being thrown during the test. We just know that, you know, this out of range exception was thrown somewhere in the method. So it would be better if we could tell which condition in the bank account .debit method caused the exception to be thrown. So we can be confident that our method is sanity checking its arguments correctly. So what they're basically saying here is we don't know the difference between was it greater than the balance or was it less than 0, because they're both giving us the same result. Okay, so look at the method being tested and notice that both conditional statements use the same exception constructor that just takes the name of the argument as a parameter. Okay, so that's just the name of the argument that has thrown the exception. There's a constructor you can use that reports far richer information, this string object string, which includes the name of the argument value, and a user-defined message. So you can refactor the method under test to use this constructor. Even better, you can use publicly available type members to specify the exact errors that have occurred. So first, define two constants for the error messages at class scope. So up here, put these in the class test, in the class under test bank account. Yeah, so they go in the class under test, then modify the two conditional statements in the debit method. Two conditional statements in the debit method. These two. So what we're doing now is passing in the variable, the amount, and then the message as well, our predefined message. So refactor the test by removing the call to assert throws exception. Wrap the call to debit in a try catch block. Catch the specific exception that's expected and verify its associated message. So this is basically what they're saying here. This library here, .contains method, provides the ability to compare two strings. So now the debit when amount might look like this. So what they're really saying is here, put a try catch around this so it catches the exception, and then you can verify yourself. You know, you can show what was the message and is it the right message that should be. So that's where string assert comes in. So this is a good example of where try catch is, you know, necessary, because we're intentionally trying to cause an exception to be thrown. So we need to catch it, and then we can, once we've caught it, we can check, is this the correct one? Is this the correct exception that was thrown? So let's grab this. I'm just going to copy the try catch part. No, we'll just copy it all actually. Okay, so when it's more than the balance, so this one. So they've put in 20, okay, and then save that and then rerun. So retest, rewrite and reanalyze. Currently the test method doesn't handle all the cases it should. If the method under test, the debit method, failed to throw this exception when the amount was larger than the balance or less than 0, the test method would pass. So this isn't good because you want the test method to fail if no exception is thrown. This is a bug in the test method, and to resolve this issue, add an assert fail assert at the end of the test method to handle the case where no exception is thrown. So rerunning the test shows that the test now fails. Okay, let's rerun. I'll just stick this in after the try catch. Assert fail. Rerun the test shows that it now fails if the correct exception is caught. The catch block catches the exception, but the method continues to execute and it fails at the new assert fail assert. Alright, you can see that now when amount is more than balance. The expected exception was not thrown. Assert fail. To resolve this problem, add a return statement after the string assert in the catch block. Rerunning the test confirms that you fixed the problem. So once we get to this part, we basically don't want it to go any further. We want to return, we want to finish the method. So one way we could do that is just the return, and because it's return void, you know, we don't want anything to return. So this is basically just saying finish the method now. Don't go any further. Because we've, you know, already asserted here. If you keep going further, you're going to assert fail. So this works when all of this passes, and as they say, there's a bug in the thing where it actually doesn't, or it shouldn't pass. Okay, so that's it. Let's see. Didn't rerun that, did I? Okay, now you can see it passes because once it passes here, it doesn't need to go any further, so it just returns. But if it didn't get in here and if nothing was thrown, then we do need to say, look, there was no exception thrown here. Alright, so it should, if it's passing, it should be getting in here. But if it doesn't, then we want to say, right, that failed because there was no exception thrown. Okay, so the conclusion, the improvements to the test code led to more robust and informative test methods. So basically, what you're doing is when somebody goes and runs your tests now, you're giving them, you know, a better, more information basically. So when you can give them more information, that's always better. The more information that you know, especially you know yourself. Like say if you have a piece of software that crashes and the developers want a debug report, you know, the more information that you can give them, the better. And what they do is they have all of these little, you know, debug messages and everything under the hood anyway, to give them more information about the problem, basically more clues to the solution, you know, or to what caused the problem. Because then if you know the cause of the problem, you're it's a lot easier to fix it. So this walkthrough uses the Microsoft unit test framework for managed code. Test Explorer also runs tests from third-party unit test frameworks that have adapters for the Test Explorer. You can, you know, look at that yourself. They've got, you know, tutorial, but I'm not going to cover that. What we're going to do is just stick with the Microsoft tests framework. This MS test project. Okay, that's just Microsoft unit test framework, and we're just pretty much going to stick with that whenever we're covering unit tests and building our own unit tests for our own classes and libraries. Okay, so that's everything for the video. Thanks for watching.